Going on now to topic 3.5, we're going to look at what are called truth tables and equivalent statements. Here we use symbolic logic to denote the truth of a statement. And for this, we're going to ask you all to write these two truth tables in your notes at this time. And I'll use a whiteboard for this. So to start us off then, we want you to put this in your homework booklet. Now, some of you might say, well, I've done this before. Yes, but bear with me. I think this is a good idea through repetition. So you want to put P and Q, P or Q, and then set up these columns, and then in a few moments we'll fill it in together. Okay, so we're going to say if P is true and Q is true, then P and Q are true. Now, if P is true and Q is false, then P and Q are false. And if P is false and if Q is true, then P and Q are false. Now, if P is false and Q is false, then P and Q are false. So of the truth tables, you're going to find the and, which is the caret. The only time it's true is if both are true. And you'll need to study that. And of course, as we do some examples later in this lesson, you'll see that. Now, we're going to use the same protocol here. Let's just do this part here first. True, true. True, false. False, true. True, false, false. I got carried away there a little bit. Not sure what I was thinking of there. There we go. Now, this is the or statement where we're using the inverted caret. Now, if they're both true, this is true. Now, if either one, P or Q, are true, then this is still true. Now, if they're both false, then this is false. This is background for symbolic logic. We're going to be asking you to do various things, and these charts, since I don't expect you to memorize them, are going to be significant in the deciding whether something is true or false. And that's what we're going to ask you based on this. So again, in the and, with the caret, the only time it's true is when both are true. Now, with the or, the inverted caret, the only time it's false is when both are false. So that's critical. So this sign, the caret or the inverted caret, that's going to be what a lot of this will be based on. All right, let's go on. We're going to go back to our lesson now and pick up where we left off. Now, they're starting us off with somewhat challenging. So this is number 1. And we're saying here that Q is true. So we have then S or Q, and then or Q. And the way this has worked is you go in the parentheses and determine the truth value of this. Well, this is an or statement. In order for an or statement to be true, only one part needs to be true. So we said Q is true. So the result of this is that it's a true statement. Now, Q we know is true. So true or true is true. If you're not sure about something, be sure to ask. Now, once again, this is kind of tricky. We're saying that this symbolic logic statement is true. Now, in order for it to be true, we're negating something that must have been false. Now, this is an or. In order for an or statement to be false, both of these had to have been false. Because when you negate that, then that's going to be true. Negating a false makes it true. So now take a moment. Based on this, which letter do you feel is the correct response? Did you select A? I believe that is the answer. Looking at example 3 now, it's P and Q. Now they're saying let P represent a false statement. So this is going to be false, and Q represent a true statement. So if you have an and, the caret, and it's false and true, looking at your truth table, this is a false statement. Because with the and, the caret, it's only true if both are true. Now, when I came across these initially, I found them challenging. Again, I wasn't that familiar with truth tables. It's been a long time. But relying on the truth tables and then analyzing. So again, let P represent a false statement. So we're negating a false, changing P to a false statement. Keep in mind now, this is an or. And they're saying Q represents a true statement. So we're negating a true statement. Now, let's convert that. Negating false makes this true. We still have our or. And negating true makes this false. So now, looking at your truth table, for the or, the inverted caret, is this going to be true or false? Again, the key is or. The only time it's false is if both are false. So this is going to be true. Now in example 5, as we look at it, it says let P represent the statement 3 is greater than 6. Now is that true or not? That's false. So P is going to equal false. Let Q represent the statement 2 is less than or equal to 9. Now here Q is true. So we have this then, once we've translated Q, which is true, or the inverted caret, P, which is false. Now, is this statement, according to our truth tables, true or false? Keeping in mind it's an or. That is true. Because in order for or statements to be false, both have to be false. Now, for number 6, it's going to take a few moments. You need to sketch this in your homework log. And we'll pause while you do that. Now, you'll notice this is set up initially as our typical truth table variety, that both are true, true, false, false, true, false, false. But now what we're doing is we are negating the P, but it's still going to be an and, A-N-D, an and, the caret, Q. So with this slight change, what are the results? So you want to have a results column over here. Once you change and negate the P. All right, take a moment, see what you get, and we'll be asking questions about this. So something like this, and what I did is I just took this chart and then changed all my truth values for negating a true. So this was false, false. This became true, true. So now, because of the caret, the and, the only one that would be true is where they are both true. And you could summarize it there. All right, let's pause, see if you have a question. Now, for number 7, they're asking us to use De Morgan's law to rewrite these statements. Keeping in mind we can consider this as P. Now, the word or is the inverted caret, and then the band has a guitarist is going to be Q. So De Morgan's law says if we're going to negate this, it's the same as reversing the or to an and negating each of these. So take a moment and see which one it would match up with. And again, I don't expect you to memorize De Morgan's law, but you have it in your notes and you could use it as needed. So the key here is the or. So this is going to become an and we're going to negate this. So the band does not play rock music. Here we see that here. There's the word and right there. And the band does not have a guitarist. So this one fits, I believe, beautifully. And it matches right up with De Morgan's law. So in looking at example 8 here we have this statement, 2 is greater than 1, and 3, and the word is or, 3 does not equal 16. Now, again, in negating this, we're going to change the or to an and then negate this and negate that. So take a moment and see what you come up with. and looking at the rationale. So we want to negate this. So negating this is going to become 2 is less than or equal to 1. This is from an earlier lesson. And then negating this, we're going to say 3 equals 16. Now notice this is an or, so we're going to have to change it to an and then now it's a matter of matching this up. And it looks like C here. Okay. Again, some of these are challenging, but take it in pieces based on what we've learned and are building on. All right, in number 9, attorneys sometimes use the phrase and or. Now, notice what's going on here. They're saying the caret and the inverted caret in a sense. So is this what usage of the word or? Is it exclusive or inclusive? You're including more. It is inclusive. And again, if you're not familiar with this vocabulary, just keep in mind that when you have a phrase like this, and or, it's including everything.